Hi students, welcome to our channel. Today's topic is parallel in parallel out shift registers. So it is under the category of different types of registers. Parallel in parallel out is nothing but we have to apply parallel inputs and output also we can get in parallel format. So it is a 4-bit register. It contains how many flip-flops? It requires 4 number of flip-flops. 1, 2, 3, 4. Nothing but A, B, C, D. Okay, now it is a 4-bit parallel in parallel out shift register. So generally registers we are using D type of flip-flops only. Why we are using D type of flip-flops? D flip-flop simply transfers input data to the output. Okay, when we are giving 0, output also 0. When we are giving 1, output also 1. So here I am taking first flip-flop, second flip-flop, third flip-flop and fourth flip-flop. 4-bit parallel in parallel. We have to take 4 D flip-flop. D flip-flop 1, D flip-flop 2, D flip-flop 3 and D flip-flop 4. So input data parallel means for the 4 flip-flops we have to apply input data. So DA is the A input, so DB is the B input, DC is the C input and DD is the fourth input. So here I am applying positive edge triggering. Bubble with arrow mark unte danni emantam positive edge triggering. So only negative edge triggering. So negative edge bubble with arrow mark unte negative edge triggering antam. So without bubble it contains arrow mark is called as positive edge triggering. Here I am taking negative edge triggering clock pulse. Negative edge triggering clock pulse. And outputs are QA and QB. QA and Q bar are complementary outputs. For first flip-flop, QB and QB bar, QC and QC bar, QD and QD bar. 4 flip-flops, 4 inputs, 4 flip-flops. Clock signals are connected parallelly. Parallel is nothing but synchronous clock signal. Asynchronous is nothing but serial clock signal. Here we are taking major output, QA output, first output, QB output, QC output, QD out. When we are applying input data, automatically we can generate the output data. So let us take here truth table of parallel in parallel out shift registers. So in the truth table, it contains inputs and outputs. So clock is the one of the input. So whenever the clock equal to 0, input data whatever it may be 0 or 1, 0 or 1, you can take 0 or 1, clock equal to 0, all the 4 flip-flops at reset condition. Okay, all the 4 flip-flops at reset condition, output data will be automatically 0, 0, 0, 0. You can take input data 1, 1, 1 or 0, 0. So that is called as initially antam. You can take 0 also, but output automatically 0. So clock initial ga 4 flip-flops ni reset chesesi output data anedi zeros వస్తాయి. So reset అంటే no value is present. Whenever the first clock pulse is applied. So whenever the first clock pulse is applied, so I am applying 4 inputs data 1, 1, 1, 1. So whenever the first clock pulse is applied, so first clock pulse is applied means 4 flip-flops. For the 4 flip-flops we are giving input data, clock signal. I think external clock signal. So 4 flip-flops are on condition. On condition means it is ready for the operation. When we are applying input data A, B, C, D. When we are applying input data, automatically output values is generated. So 1 is applied here, 1 is applied here, 1, 1, 1, 1. So output also automatically 1, 1, 1, 1. So ఏదైతే input data ఇస్తామో same output value అనేది present అవుతుంది in registers, generally D flip-flops. Coming to the timing diagram. So timing them. So this one is logic circuit, truth table. Let us go for the timing diagram. So in the timing diagram, what happens? You can see. So there are relation between the timing in the timing diagram. There is a relation between the input and output values. Input is default input is a clock signal. Clock is the default input. So and major inputs are DA, DB, DC, DD. And outputs are what are the output values? So these are inputs. Outputs are QA, QB, QC and QD. So when we are applying input data 0 or 1, we can take 0 or 1. So generally I am taking 1 value, where for initial clock pulse, here also I am taking 1 from the truth table. So from the truth table values, here also I am taking 1. This one also I am taking 1. Okay now. So what are the output values? All zeros at reset condition. Reset condition means draw the one straight line, flat line, 0, 0, and 0, and this value also 0. Okay, whenever the first clock pulse, for initial clock pulse, input values and output values. So what about whenever the first clock pulse is applied? First clock pulse, negative edge triggering means one negative edges to downfall edges to second downfall. Okay now. So whenever the first clock pulse, it is a combination of logic 0 and logic 1. So whenever the first clock pulse is applied, input data 1 and 1, 1, here the value 1, and this one also 1 and 1. What happens? All four outputs are on condition. On condition means same data will be transferred to the output. 1. So this value also 1, and this value also 1. And what about fourth value also 1. Four outputs are 1s. Okay. Input data and output data. From the truth table, we have to draw the timing diagram. So this is about parallel in parallel out shift register.